Hi everyone, this is section 1.5 equations, and I can tell you that equations are everywhere and you will see equations for the rest of your math life. They may look a little bit different here and there, but equations are something we are always dealing with, whether it be calculus or differential equations, linear algebra. The point is, we got to know equations. So we're going to start today with just kind of a refresher of some different kinds of equations that we may see in the future. After we've done a little bit of work somewhere else, we may end up with an equation that we need to solve. So we'll start with the idea of an equation with one unknown. That simply means it has one variable. So as you can see, we've got our first example is an equation with one variable. It only has x. So our job is to find the value of x that makes this equation true. So with something like this, my goal is to get x on one side and the solution, the number or numbers that make it true, on the other. So for something like this, we're going to use these properties that we know. In this case, we'll start with the distributive property. So if you want, you can go ahead and distribute everything on the left side. So if you want to pause and do that and then combine any like terms on the left side, that would be our first step. So go ahead and do that if you'd like. I will do that as well. I'm going to have 4x minus 8 plus 2x minus 6, and that's going to equal 8x. And then combining my like terms, it looks like I will have 6x, 4x plus 2x. And then I have a minus 8 minus 6, so that'll be a minus 14, and that equals 8x. Then what I'm going to do, again, in order to get my x's all on the same side, I'm going to subtract a 6x to both sides. So remember, with equations, that's different than having an expression. There's not a whole lot we can do with expressions. We can multiply by 1, we can add 0. Once we have an equation, that equal sign, this side equals this other side, then we have all these things that are available to us. But whatever we do to one side of an equation, we need to do to the other. So I'm subtracting 6x, and then I'm going to divide by 2. And you can see that x equals a negative 7. Notice that I did put the x on the left side and the number on the right side. You could have negative 7 equals x. It's the same exact thing. I just like seeing my x first, but you can always do it and then switch it. It's totally fine. Now I'm going to write this as negative 7 in what's called a solution set. So this is what's called a solution set. And it is literally the set of the solutions of the equation. So notice I have these like brackets around it. That's set notation. And it's just telling people this is the thing that makes this true. There's kind of different thoughts on whether it's needed or not, but understand that what we finished here in the end, like what this is still an equation, x equals negative 7. So if our job is to find the solution to this equation, the solution to the equation, the thing that makes it true, is negative 7. So I've put that in a solution set. Once we have, so that's our basic idea with our one unknown, so that linear equation of one unknown. When we think about quadratics, now we have a higher degree. So notice we have an x squared in this that we didn't have in the first equation. And so typically what this means is, if you remember from the other work we've done already with quadratics, there could be a few different solutions here. There could be 0 solutions, there could be, or 0 real solutions. There could be 1 real solution, there could be 2 real solutions. So that means there could be imaginary solutions. There's a few different things that could happen. Multiple different ways to solve a quadratic. Most people would say that if you're able to factor a quadratic equation, that would be the most straightforward, if that's a possibility. So notice that this one does give us a hint. It does say solve by factoring, and that is the first thing I would try. We have everything on one side of the equation. We also have it going from the highest degree down to the lowest degree of the variable. That's how I would like to see it. That tells me that since I have a trinomial, if it does in fact factor, then it's going to look like this, 2 binomials, most likely. So we only have a couple options for 2x squared, and we actually only have a couple options for 5. That's a prime number. It's just 1 times 5. So it's really, where does the 1 go and where does the 5 go? because I want that 9 in the middle, that's a fairly large number for the fact that the other two values are not so big. And so I know that that 2 needs to get multiplied by the 5, so that outer idea. So when we multiply out, that's going to give us 10. And when we take away 1 from that, 1 times x is 1x, that's going to give us the 9. Because the 9 is positive, I want that larger multiplication to be positive, and subtracting something that is smaller. This is the way to get a positive middle term and a negative constant, to have one of each type, sign, I should say. Now, here is the key thing with equations like this. Now I have something times something equals 0, and we have a property which says that when a times b equals 0, where a and b can be anything, but if a times b equals 0, then either a equals 0 or b equals 0. Because in order to get 0, one of those things needs to be 0. That's the only way that that can happen. It's typically called the zero product property or the zero factor property. So what it tells us is that once I've done this factoring, I can take each of my factors and I can set them equal to 0. So either 2x minus 1 equals 0 or x plus 5 equals 0. And then that allows me to solve each one for x. Obviously, at any point in time, you can pause, you can work on something yourself, see if you can get the answers, and then come back and check, and you get that immediate feedback of knowing whether your answer is right or not. And if for any reason it's not, you're able to fix it. So I'm getting 2 answers here. I'm getting 1/2 and I'm getting a -5. And so those are our 2 solutions. So we do have 2 real solutions here, -5, 1/2, and there we go. I'm putting them in my solution set. So know that this zero product property or zero factor property only works when it's equal to 0. We do not have any other number that you can put there and have that same property. So that's why typically with a lot of quadratic and other equations, we do move everything to one side. It depends on the equation, but for something like this is exactly what we want, because if we can factor it, we have factors, and then we can set each one equal to 0. Okay. Here's another quadratic, but notice it's written slightly differently. And the key thing to see with this one is it's not like term plus term plus term, plus or minus terms, anything like that. Because the first term is actually something squared. It's a whole quantity squared. So you could do this a couple different ways, and that's what's great about quadratic equations, is that you could, if you wanted to, multiply this out, see if it factors. If it doesn't, use something else. There's options. However, because I have this whole thing squared, I think that the best idea is to use something called the square root property, which says that if you have something squared equaling a number, so notice I'm contradicting what I just said, putting the 5 on the other side, but again, this is not like the problem that we had before. If I make this into something squared equaling a number, I can use the square root property, which says that now I can think about the idea of taking the square root of each side, because square rooting and squaring are opposite operations. I want to free that x. That x is now in squared jail. In order to free it, I want to do the opposite of the squaring. That's a square root. So now I can do that. If I take the square root of something that is squared, I'm going to get x plus 1. If I take the square root of 5, then I need to think about plus or minus the square root of 5. So the idea behind this is essentially that it's saying that, like, if a squared equals k, where a is anything, like what I have there, x plus 1 squared, that means that a equals plus or minus the square root of k. Reason for that being is that I could have a square root of k, I could have a negative square root of k, and when I square it, both of those things are going to give me k. And that's why we have to do the plus or minus. Now, to finish this, I just still need to isolate the x. I just need to get that x by itself, and that's going to require bringing the 1 over, -1 plus or minus the square root of 5. These are not like terms. You cannot combine them together. So at this point, you are done. Understand that this is 2 solutions. This is -1 plus the square root of 5. this is -1 minus the square root of 5. It is not uncommon to see it as -1 plus or minus the square root of 5 in our solution set, but it is two solutions. You might be able to kind of see how this could work. If I plug back in, say, -1 plus the square root of 5 back into my original, notice I'm going to have a -1 plus the square root of 5 plus 1. The -1 and the +1 simplify to 0. I have square root of 5 squared. Square root of 5 squared, 5. 5 minus 5, 0. Very similar to the other solution as well. So my point is just, we can check that, we can see that it works. So that's key. It's the values that make this equation true. Okay, so we're still working on this idea of quadratics. And there's another method that we have, which is completing the square. So completing the square is one that is helpful in certain situations, but it's probably not going to be my go-to often, but we do use it in some other things too. So completing the square has us doing this. It's a very helpful, or it works the best when the middle, so notice we have a quadratic, everything's on one side. You should see this does not factor. And so factoring is not going to be a way to go for us on this one. But because the middle term is even, completing the square, it could work. We can do it. So the first step here is going to be to bring the first two terms to one side. And then, again, now I feel like I just shouldn't even have mentioned that before. I'm actually going to bring the 3 to the other side in a situation like this, so that I have something that looks like this. Okay, so what my job is now is to basically make it so that I can use my square root property. That's the goal of this completing the square. Can I get it so that I have something squared equaling a number? In order to do that, I'm going to make it so that this thing, this second line here that I have on the left-hand side, is a perfect square trinomial, meaning that it can factor into something squared. So the way to think about that is the number that I need to add there is, again, the thing, so that if I factor it, the middle term, is a -8x if it gets multiplied out. And then the last term is something squared that fits that -8x. So the value that we need right here, maybe I'll put a big arrow here, whoop, whoop. The value that I need right there comes from, this is like the formulaic way to do it. It is figuring out what your b is. B is, so when we're dealing with quadratics, this is how we look at them. Ax squared plus bx plus c. So it's the coefficient of the middle term. So b in our case is -8. Then we take half of b. That's not too bad. Then we square it. So it's b over 2 squared. And that gives us 16. So that tells us that the number that I need to add over here is 16. But of course, this is an equation. If we do something to one side, we need to do it to the other. That's what keeps that equation balanced. What this does is this allows me to take that left-hand side and factor it. It is now a perfect square. So it is something times itself. So notice, this is the really easy way to look at it, is that the value that's going to go into my factoring here is actually just b over 2. So notice b over 2 is -4, and so that's what's going to be in here, x minus 4 squared. If you were to multiply that out, you're going to get what we have above, and that's over time, you'll just see that pattern recognition. On the other side, -3 plus 16 gives me 13. Nothing too exciting there. But now, take a look, it looks like what we had above. Now it's like this one more step thing that we had to do, but now we have this perfect square on the left-hand side, we have a number on the right side, we can use the square root property, and we can take the square root of both sides, and we're gonna have plus or minus the square root of 13, And like we had before, we're then going to add that 4 to the other side so that we have x by itself. That is 2 solutions, don't forget that. And that's going to give us 4 plus or minus the square root of 13 in our solution set. And those are our 2 solutions, again, using this method called completing the square. So far, we are still looking at quadratics. So do notice we've got quadratics still happening. And there's one really very common way to solve a quadratic equation called the quadratic formula. So this is going to work all the time. It doesn't matter what kind of quadratic you have. If it factors, you could still use the quadratic formula. Square root property, you could still use the quadratic formula. It's always going to work. You just have to have your quadratic in the form, like I just showed, ax squared plus bx plus c equaling 0. If your quadratic is of that form, you're going to be able to use what we have above here. This is saying that the solutions to the quadratic are found by simply identifying the coefficients of the different terms, and of course the constant c, and just plugging them into this formula. If you want to remember the formula, you could Google this on YouTube, go to YouTube and you could put in quadratic formula song, and there'll be like a lot of songs that can like remind you of how to memorize the quadratic formula. As you can see, it is negative b plus or minus the square root of b squared minus 4ac all over 2a. So it's a good thing to just remember, but we're going to use it today. So taking a look at our quadratic here, it is in the correct form. We've got everything over on one side. We have it in order of degrees going up to down. And what we find is that a equals 2, b equals 4, and c equals negative 3. And then what the quadratic formula says is you're just going to take those, and notice I'm going to start with x equals. It's just telling me that my solutions are going to be negative b, and again, you can pause this, see if you can plug in the correct values. So negative b, which in our case is negative 4, plus or minus the square root of b squared, which is 16, minus 4ac, so 4ac all over 2a, so 2 times 2. And we don't leave it like that. That is a little, still too rough. We're going to simplify. And so really what that typically involves is combining what we have underneath the radical. So notice we're going to have 16, and then 4 times 2 times 3 is a 24. And that's a negative and a negative, so that's a plus 24. So we're going to have 16 plus 24. All over 2 times 2, which is 4. Now, some students will say, can I simplify this? I see a 4 and a 4. No, you can't. Not yet. We will get there. But you should see this as 3 terms. That's a really key thing to see here. There are 3 terms. There is one term, then you got that plus or minus the second term, and then you've got a third term. If you want to do any simplification, you need to wait until you have all 3 terms with a common factor before you can simplify. So we'll get there. So 16 plus 24 is 40, and then we're over 4. Not quite yet. Now I'm going to have a negative 4 plus or minus. So the square root of 40, thing to think about here is 40 is 1 times 40. It is 2 times 10. It is 4 times 40. It is 8 times 5. But the 4 times 40 is the one that you care about because 4 is a perfect square. So we are going to rewrite 40 as 4 times 10. We are then going to remember our radical properties, which says we can split this apart so that we have the square root of 4 times the square root of 10. Square root of 4 is 2. So now we have 2 root 10. And in that denominator, we have 4. Then what we notice is there's a common factor in these 3 terms. So don't forget, we've got 3 terms here. We've got 4, we've got 2 root 10, and in the denominator we also have 4. So we have a I can do this a couple different ways. How do I want to do this? Yeah, let's go with this. So what I'm going to do to show you here is if I pull a 2 out of the numerator, I have negative 2 plus or minus the square root of 10 all over 4, which is of course 2 times 2. Now I do that just to show you that it tells us that we can simplify a 2 here with a 2 here. Those are both factors, factor of the numerator, factor of the denominator. And so that simplifies to 1. And then we're left with x equals negative 2 plus or minus the square root of 10 over 2. This is completely simplified. There's no more factors that we can take out of the square root of 10. So there's nothing else we can simplify with those other 2's. So those other 2's need to stay. And it does give us our solution set of 2 answers, negative 2 plus or minus the square root of 10 over 2. That is 2 real solutions. They are irrational due to the square root of 10, but they are still real solutions. If you were to graph this, you are going to see a parabola. We'll talk about this more in the future, but anytime you solve this quadratic equaling 0, there is the thought that you could think of it as a function. And if you think about the quadratic as a function, we're thinking about that this is the place where the parabola has its x-intercepts. We'll be talking a lot more about that in the future, but that's the idea. Okay, so we still have more more equations to do, different types and stuff, so we'll do that next.